Start now. I'm Rob MacDonald, Chair of the Merseyside and Western Cheshire Local Network and Chair of the Local Network's Energy and Environment Group. I would like to welcome you to this evening's webinar along with my co-host Carl Formstone. The Mersey and Western Cheshire Local Network is based in the northwest of England and includes the Isle of Man. The local network has a number of specialist groups, one of which is the Energy and Environment Group. Next slide, please, Sagnik. The Energy and Environment Group members are focused on the issues of providing energy whilst protecting and improving the environment and organising free-to-attend events and technical visits. Because of the impact of the COVID-19 pandemic, we are presently using Zoom webinars for our events. The group is focused on deliberately wide-ranging. The group's focus is deliberately wide-ranging to embrace all aspects of the provision, distribution, usage of energy, and the associated environmental issues from technical and an engineering perspective. The focus of the Energy Environment Group is in the following areas: the generation of electricity using low carbon technologies or with carbon capture, the transformation, distribution and storage of electricity, the issues of environmental impact and mitigation of the generation, transmission and distribution and utilisation of electricity, the use of hydrogen in the energy supply system, including hydrogen generation, storage and distribution, greenhouse gas reduction, including carbon capture technologies, the use of energy in transport systems. If you have any proposals for future events that fit in with the group's focus, I would be pleased to hear from you. My contact details are below, and that's robert.mcdonald@ietvolunteer.org, and my mobile number is 07470 500 286. Next slide. Our next webinar will be on Tuesday, the 27th of April at 7 p.m. BST. It will be presented by Martin Land, Project Director of the Mersey Tidal Power Project. Got thrown by the wall. This evening's webinar is on the topic of how renewable energy technology plays a role in achieving our net zero goal. The presentation will be given by Sagnik Murthy. Sagnik is the Head of Client Relationships, Ports, Rail, Nuclear at UK Power Networks, and currently is focused on the development of collaborative energy infrastructure solutions with customers that harness distributed energy resources and new technologies such as battery, energy storage, electric vehicle infrastructure and microgrids, along with high voltage power distribution solutions. Sagnik is a professionally qualified engineer, member of the IET and an MBA from Thunderbird USA with 20+ years in international business management experience. In the last 12 years, he's worked in the clean energy sector, starting with offshore, with wind, with GC Power Systems, onshore wind with Vestas wind turbines, and energy storage with ABB. He likes contributing to articles and enjoys public speaking opportunities to promote technology, solutions, value positions, while also educating audience about energy transformation happening in the UK and globally towards a smart, digital, clean future energy. He is passionate about renewable energy and the role it plays in the transition towards net zero to 2050 ambitions. He firmly believes that it's imperative to enable rapid and widespread deployment of renewable energy technologies for society to achieve a more sustainable energy independence. Now, Sagnik, I'm going to mute myself and hand over.
Rob, you're on mute, but that is okay. Rob, you have muted yourself.
Right. Sorry about this, friends. I'm not experts on this. Today's webinar arrangements, we'll have a presentation of about 40-50 minutes. We'll have a Q&A session after the presentation. Please submit your questions using the questions box. The webinar recording will be on our YouTube channel. Search using IET Mersey in Western Cheshire, and that'll be in about a week's time. And if you want a continued professional development certificate, please email me, robert.mcdonald@ietvolunteer.org.
And now I'll take over.
Thank you, Sagnik. Rescue me. Thank you.
Good evening, everybody, and thank you, Rob, for the warm introduction and setting the scene. I'm delighted and honored to be invited to present on this topic today. I hope you'll join me on the journey over the next 40-50 minutes to explore and see how renewable energy technologies play a role in net zero transition over the next 30 years. And before we dive in, I just wanted to give a quick introduction to UK Power Network Services. And UK Power Network Services is a business-to-business energy infrastructure solutions provider, and also a strategic energy partner to clients who require power systems, design, build, operate solutions, and we help them integrate new technologies and also from which they can derive commercial benefits. And we've been doing this for over 50 years in the critical infrastructure space, serving aviation, rail, ports, defense, the nuclear sector. And to distinguish ourselves from the distribution network operator, which is UK Power Networks, they are the electricity system operator for London and the Southeast, delivering electricity to 8 million residential and business users. UK Power Network Services operates nationally, is accredited to all the international standards, and has a very high safety record as well. So over the last 5 years and more, we've achieved over 5 million working hours since the last time due to injury by the sister companies in the group, like Evershore Trail, Northumbrian Water, and West, and the Telecoms 3. We provide a full end-to-end turnkey solution for businesses, which can be from capital financing to consulting, technologies, engineering, construction, operation maintenance, asset management, and contracting services as well. That will help you connect to the network. So that's about us. And let's dive into the presentation and the discussions. I'll very much look forward to the question and answer session at the end. So let's take a look at the UK energy market trends. And let's kick it off with what is the energy transition about? What is the energy trilemma? In June 2019, the UK became the first major economy in the world to pass laws to end its contribution to global warming by 2050. What that means is they wanted to get their emissions to net zero, which is the net of the emissions which you emit or you can sink in by 2050 to zero. And in support of that, late last year, they also unveiled a 10-point plan for the net zero transition, followed by the National Infrastructure Strategy, the Energy White Paper, and it sets out a vision that 65% of our power should come from renewables by 2035. And if you think about it, it's 37% right now. So that's a big quantum jump, and that shows the scale of the ambition that the government has. And it's also underpinned by the findings by the Committee for Climate Change that visualizes the scale of the challenge. In order to achieve net zero by 2050, you need to quadruple your low carbon generation and electricity system. Offshore wind needs to grow from 10 gigawatts to 75 to 100 gigawatts. Hydrogen that is currently produced 27 terawatt hours, that will need to scale up to 370 terawatt hours. And carbon capture and storage, which is currently at zero, you'll need to capture about 180 metric tons of that CO2. You have to afforest trees, then 21 million homes with low carbon heat, zero carbon cars, which will go up from 250,000 to 35 million, major changes to your diet as well, and large scale landscape as well. And you got 1 billion seconds, which is about 30 years to achieve this. And the energy trilemma is a buzzword which you may have heard in the industry. What it means is a very simple way is reduce energy costs, you reduce a carbon footprint while still maintaining your network resilience. So on the triangle on the right, you see three pillars: energy security, affordable energy, and whether it's sustainable energy. And it may mean different things to different people, different businesses. Think about emergency services and hospitals. For them, the reliability of their energy supply is crucial. So that's where it stands at the apex of the triangle. Or a blue chip IT company, for them, might be a combination of energy sustainability, which is sourcing low carbon electricity and reducing the emissions, but also having a reliable electricity supply. So it's somewhere in the middle on that continuum. And for a business like retail centers or shopping malls, which are very cost conscious, so energy costs is an important metric, it's the most important metric for them. So different businesses, different customers, different people, it means different things, but having a holistic approach to that is key to this challenge. Continuing with the trends, what this graph shows you is the variability in the price of electricity in the wholesale market. And what is driving this is as we transition to renewable sources. So significant amount of small-scale renewable generation has been connected to the distribution network at 33 kV and below. And renewable sources, solar generation or wind power, they are intermittent, they are variable, and which actually makes wholesale electricity prices quite volatile, which also means that the cost of managing and balancing the electricity network has also increased. So it's important for businesses to develop an energy strategy that actually considers all these options, this variability, and how they can source electricity, which is low carbon, but also is meeting the requirements, which avoids the variability. And so we have to recognize these trends and make arrangements for that. The UK has made good progress till date in decarbonizing the electricity generation. And of course, coal is going to be phased out by 2024. In April 2017, the UK had its first coal-free day. And 3 years later, the summer of last year, April to June, had a stretch of 67 days where you had coal-free period. The energy system is now cleaner, intermittent, decentralized, and renewables used to be 7% of the generation mix in 2010. In 2019, it was 37%, and this is forecasted to become about 65% with the government's plan as well by 2035. Most of, a quarter of it is connecting at distribution level, so it's not at the transmission level as well. And the regulator for the electricity and gas markets recognizes this change in the landscape, and they're asking and mandating the network operators to actually anticipate investments, to make investments in infrastructure that will allow our streets to become green, so you can accommodate electrified heating, have more rollouts of electric vehicles. And local energy systems are also becoming part of the mix, more and more community energy schemes. And as I said, LEMs, the picture on the right is a picture taken from Centrica, courtesy of them. They had first trial of this local energy market in Cornwall. The solar battery storage was installed in 100 homes. They were aggregated together to form a virtual power plant. So that is not a conventional power plant, but an aggregated virtual power plant, which was then supplying electricity to the grid, also providing flexibility services and participating in the frequency response market. And you'll hear flexibility more and more in the energy market as well, and which I'll cover in the subsequent slides. This is just a snapshot of how the renewable generation stands today. So you can see that 37% comes from renewables, about 17% comes from nuclear. So Renewables and nuclear, that gives you low carbon electricity generation of about 54%. But that is not enough. And coal hit an all-time low of 2.1%. Going forward, you will have more innovative sources like floating wind, wave and tidal power, green hydrogen, and a massive expansion of battery storage to take us to those net zero emissions as fast as possible. National Grid every year publishes its future energy scenarios. It expects a boom in renewable energy projects, and it should see about 3 gigawatts of new wind power capacity and 1.4 gigawatts of solar capacity generation every year from now until 2050, alongside a widespread rollout of electric vehicles, which will effectively act as smart charging batteries to help balance the electricity grid. What the graph on the left shows is that but 90% of the electricity in 2050 will be generated from 4 technology types. So the 4 colored bands at the top, so that would be bioenergy, which is biomass with carbon capture and storage. Then you would have solar, wind, nuclear. That forms about 90% of the electricity in 2050. And the chart on the right shows that in 2019, that is the electricity demand at the moment of the network. And as you have the transformation, behavioral change in society, and the consumer transformation led where consumers become more and more green, conscious about the electricity they consume and the type of sources, that would have the lowest demand on the system. And if you did nothing, if there's a steady state progression, that is where the consumption would be. You can see the mix. So that green bar shows that there will be blended gas. But if there was a system transformation, the blue shows the hydrogen element, because there will be hydrogen for heating as well, which will be part of the mix. So there are different routes to that net zero state phase or state, and which is a combination of using these different technologies, gains in energy efficiency, and electrification of transport as well by using wind and solar power. You will also see that offshore wind, the government has put its backing for this sector, and by 2030, there will be about 40 gigawatts of offshore wind deployed, and which will have about 1 gigawatt of floating offshore wind. So basically a quadrupling from the existing 10 gigawatt installed capacity to 40 gigawatts by 2030. And this is also acknowledged by the oil and gas majors, the Totals, the Shells, the BPs of the world are increasingly making investments in offshore wind. By the end of the decade, they will have more offshore wind turbines than oil rigs. And pictures on the bottom show, like in 2010, that's an image of an offshore wind farm, the Baltic 1 being installed. And that turbine is a 3 megawatt turbine, and that had a diameter of 90 meters. The turbines to be installed at sea in 2030 will each be 15 to 20 megawatts. That's about 5 to 7 times jump. And the diameter would be 230 to 250 meters. So just a graphical scaling shows that it's almost as tall as the Eiffel Tower. So these huge monsters out in the sea, 50% generation capacity, producing clean electricity. The image on the bottom right, which shows the offshore wind turbines at sea. And it's very clever that the developers of these wind farms have recognized that the service vessels, they will also become low carbon vessels and maybe electric fueled as well. And they would have the charging buoys in the sea, which would be fed from an offshore substation platform. And the vessels can come in and plug in to those charging buoys. The plan is also that ships in transit could use them in future as well. So you see, technology is moving, applications are moving, and it's all enabling that. Hydrogen. This will also be part of the mix, certainly. Low carbon hydrogen. You've got 3 levels. You've got gray hydrogen, blue hydrogen, and green hydrogen. And most of the hydrogen produced is gray these days. It's industrial process where you do steam methane reformation. when natural gas is treated with high temperature steam. When the carbon dioxide is vented to the atmosphere, that is gray hydrogen. Blue hydrogen is when you capture the CO2, which is a byproduct of the process. And most of the hydrogen produced uses SMR, 95%. And CCS actually allows net zero operation for electricity production and hydrogen generation from fossil fuels. And the next level would be green hydrogen, but blue hydrogen still produces about 10 kgs of CO2 for every kg of hydrogen. Green hydrogen is the cleanest form of electricity. So the cost of producing this is a bit high, but it's green hydrogen because you're using low carbon energy sources such as offshore wind power or even nuclear to provide that electricity to electrolyze water. And hydrogen is seen as having multiple applications. So hydrogen for heating, hydrogen for long distance freight, whether it's road and shipping. You may have also hydrogen aircraft in the future. Hydrogen as an energy storage mechanism for excess renewable energy. Hydrogen for heavy industry, steel production. We use hydrogen instead of coke for the production process. The UK government is going to publish a hydrogen strategy in 2021 and has already begun a consultation. It's aiming to deploy about 5 gigawatts of low carbon hydrogen production capacity by 2030, funding in place and carbon capture and storage clusters to be set up around the country, pioneering hydrogen heating trials, a hydrogen neighborhood and a town before the end of 2030. The images on the right, in the bottom right corner, that shows a project being developed by Ørsted and where they are using the wind produced from the turbines offshore, which will feed in electrolyzers from ITM Power to produce hydrogen. And this hydrogen will be used by Humber Refinery, owned by Phillips 66, and reducing the CO2 emissions from the refinery. So that, and there are other projects as well in Europe, where Shell and Eneco are going to produce hydrogen using offshore wind. The Hornsea project, offshore wind project in the UK, will also be producing will be supplying electricity to produce green hydrogen. And the other example, the picture on the right, which might be intriguing for yourselves, is plans for offshore production of hydrogen directly at sea. You couple the offshore wind turbine with an electrolyzer plant and with solar panels on the upper deck as well. So this is a concept picture, but in reality, like Siemens and the Mersey are also exploring this option. So you would see hydrogen produced right where the source of electricity is, and thereby reducing some of the efficiency losses in transmitting that electricity and producing that hydrogen. And you might question place for nuclear in the renewable presentation, but nuclear, let's not forget, is a source of low carbon electricity. And the government is also investing and providing necessary funding because it will support large-scale employment, and the technologies that are being supported are investment of about 525 million pounds in small modular reactors and advanced modular reactors. And future will see these small modular reactors which can produce both power and heat to produce emission-free hydrogen as well. We will need about 12 to 13 gigawatts of nuclear reactors of all types that would use electrolysis, steam electrolysis using waste heat, thermochemical water splitting to produce green hydrogen. What you would notice on this slide is whether it is the new nuclear technology solutions or the conventional nuclear power plants, they're all rejigging their business plans to keep themselves relevant in the energy mix, especially because nuclear also provides a stable base load of electricity that supports a power system when variable sources of energy are not available on cloudy days and windless nights. So projects, Sizewell C, which is expecting to be consented early next year and start construction and of plant, is looking to will have developed business and commercial models to deliver power, heat, hydrogen. Bilfin, North Wales, the Moorside Clean Energy Hub in Cumbria, all looking to combine the nuclear projects with renewables alongside wind and to produce hydrogen to widen the business case and commercial viability of the projects. The impact of the changing energy landscape, what does it mean? I talked about flexibility at the start of my presentation. The variability of wind, solar energy has an impact on the network. And as more and more, like historically, like you had these large rotating machines, coal plants, steam turbines, hundreds of tons of rotating mass was available. So when these machines, if they were tripped or if there was a loss of power, the frequency of the system wouldn't drop dramatically from 50 hertz to say 48 hertz in an instant. They would slowly drop. National Grid's remit is to maintain the system frequency at 50 hertz, 49.5 to 50.5, and they do that by balancing the supply and demand. And that is where the flexibility kicks in. So with loss of all these heavy machinery on the system, like frequency would shoot up if the supply is more than demand. The frequency would fall below 50 hertz if generation is less in demand. And in response, National Grid requests that businesses or these plants to respond to that. So if there is a drop in frequency, you need flexibility from the system. So there's a signal sent to the providers to ramp up their generation. And now batteries are very well placed to provide this instantaneous response, synthetic inertia. There are also other technologies out there, such as synchronous condenser machines or rotating machines, which do not generate active power, but they provide synthetic inertia, short circuit current, and voltage control. These are very important technical parameters and support services provided to National Grid to keep the grid stable and equilibrium. And a benefit or upside for the consumer is that when excess supply on the network happens, because on a sunny day, when in summer, when there's a lot of production of electricity and there's not enough consumption, you could have negative electricity prices. And that is time where energy suppliers like Octopus have introduced time of use tariffs for customers where the customer earns money to use the electricity on the network to charge batteries or run their washing machine. So there's a benefit as well. At the bottom of the slide, and of course I'll make the presentation available, is a YouTube video which you could click, watch how does this play out, the variability of distributed energy and how flexibility plays a role in our lives. And very simply put, is like all energy users can change the electricity demand in 3 ways. Either you turn down the use of electricity, you change when you use electricity, or you turn on the or increase the production from your on-site generation. And businesses can do it as well. For example, on windy or sunny days when demand is low, renewables output is high. The new income streams from ancillary services, what we call the frequency response, or balancing mechanism, or energy arbitrage, which is charging it the prices are low and supplying it prices are high. So the BEIS analysis suggests that flexibility from demand side response, storage, and interconnection could reduce system costs by up to £12 billion a year in 2050, compared to a system with extremely low level of flexibility. More and more flexible sources of generation and flexible technologies will be coming online as well going forward in the years to come. What does that mean for businesses as well is to have an energy strategy which considers all this changing change in system that is happening. And as you increase your operational requirements, whether you're electrifying your cranes or you're deploying EV charging, manufacturing processes, hydrogen production, you should be considering your demand forecasting, evaluating the energy sources that are out there, your carbon reduction targets for your business, what is a policy environment that is impacting this, whether it's affordable and secure, and the profitability of your business operations, whether you're in the port sector or you're in the rail sector deploying battery trains, or you're a logistics or fleet operator, a commercial industrial business, or the aviation sector as well. And so we talked about the electricity networks and the system. Let's look at how it impacts transport and heat, decarbonization. So 451 million tons of CO2 was the total domestic greenhouse gas emissions in 2018, and 28% of this came from the transportation sector. This sector will require transformation if the UK has to achieve its target of net zero emissions by 2050. Now, passengers are increasingly considering the sustainability impact of their journeys from door to door, and that not only means carbon offsetting the flight, but electric taxis and trains looking at the future, even electric aircraft. We need to create an infrastructure that supports them in making these positive choices. At the same time, absolutely unforgiving for any delay in their journeys. So making resilience of the infrastructure vital. So increasing electrification poses a challenge to the grid. Hydrogen production using electrolysis could be a solution. There will be rising uptake of electrified personal and public transport, but there is no silver bullet here. Rather, a mix of solutions is required. As you can see, like battery electric vehicles, so EVs, this will grow. Electricity's demand would be driven by increased electrification, transport and heating. The UK could have 11 million EVs by 2030. And EVs can support the rollout of renewables because the batteries in a car can be used to store excess generation, export to the grid when required. The smart charging technologies, what we call vehicle-to-grid solutions, to shift significant demand to off-peak hours. By 2050, up to 80% of the households with an electric vehicle will smart charge, and up to 45% will actively provide vehicle-to-grid services, so offering flexible electricity to manage the peaks and the drops in demand as well. But in order to do this, the challenge will exist to scale up the charging network, deliver the 25 million vehicle charging points that will be required nationwide. And some argue that government intervention is required to underwrite the construction costs of the national charging network, particularly in rural areas. So there is a scale of challenge, there's a scale of ambition as well. It will all play out, but it will happen. Now, there are about 32,000 buses in the country, and they will also need to go electric. We're going to see more and more electrification of commercial vehicles, starting with light vans. The product range is limited, but growing. Very few large heavy goods vehicles in the market. So 2018 had about EVs accounted for 21%. As this grows, you could see up to 30% increase in the electricity consumption by 2050. And a town with 200 electric buses could about save around 7,400 tons of CO2. The city of London plans to convert 9,200 buses to electric by 2037. Then the challenge is, how do you respond to that infrastructure deployment? There will be a combination of electric buses, there will be hydrogen fueling infrastructure also required. The images on the right show examples of projects that UK Network Services have deployed in the City of London, one with UPS to electrify their fleet from 65 vehicles to 170 vehicles. There's a huge demand in the electricity required through a combination of battery storage that was deployed at site, active network management solutions. They could accommodate this growth in the vans that were deployed without requiring excess grid connection capacity. The example on the bottom shows a stagecoach garage with electrified buses operating in West Ham area, in East London. Aviation, reducing greenhouse gas emissions, and what is happening in aviation. At the moment, It is tough times in the aviation sector, with the levels of activity not expected to return to pre-COVID-19 levels for the next 2 to 3 years. But return they will, as they are a key driver of the global economy. So aviation as a sector is looking to reduce its environmental impact using sustainable aviation fuels that blend greener fuels into kerosene. The Jet Zero Council is going to accelerate the deployment and adoption of new technologies. There's a market for zero emission aircraft to enter into service by 2030. The government is also investing in R&D into the infrastructure upgrades that will be required at airports to move to battery and hydrogen aircrafts. Airbus has unveiled some concept aircrafts known as Zero E, which are all hydrogen hybrid aircrafts. There are electric planes being tested and being rolled out as well. Big industrial names from Boeing to Siemens to Rolls-Royce are involved. And in the short term and more immediate environmental impact can be made by taking advantage of the decentralization of electricity networks like microgrids at airports, which London City Airport, this was an example where the port, with its expansion plans, they're deploying solar PV and CHP plans to reduce its emissions, but also provide a microgrid solution which would make it more self-reliant on the electricity that it produces and services local demand. We also have fleets of buses and servicing vehicles that will operate in the perimeter. They can be converted to electric vehicles as well. So some more immediate impacts on the emissions at airports. Maritime. How do you strike a balance between resilience, expansion, and decarbonization? Now, shipping is amongst the only industries not covered by the Paris Agreement on climate change. It currently contributes to 8% of global greenhouse gas emissions, burning as it does dirty, heavy fuel oil. Now, ships fueled by hydrogen and ammonia, significant numbers are about a decade away. In the next few years, you will see a few more coming online. There are about 66 projects and 19, 21 initiatives related to fuel production used from hydrogen in some form. You'll see more and more ammonia as well being taken up, because what you have to remember is hydrogen is a feedstock. Blue ammonia, gray ammonia, green ammonia, it all stems from hydrogen. So the hydrogen is a feedstock that will provide these fuels. And the sustainability challenges is reducing the carbon dioxide, the NOx emissions, the sulfur dioxide emissions. There's a red diesel. At this moment in time, the port equipment run on red diesel and get subsidies on that. But by 2022, the Department for Transport is advising them that this subsidy will be lifted. So ports are looking at how can they reduce the impact of the red diesel levy and electrifying their operations, which means electrifying the cranes, electrifying equipment on the port infrastructure, which means there's a more demand on the electricity network. How do they cater to that? And they will also be sure to ship power requirements to reduce emissions and noise levels around the port. Because when they're moored at port, container ships, ferries, offshore vessels, they can use a shore power electricity to provide their onboard auxiliary supply. Thereby, they're not running the diesel engines to provide this power. You'll also have hydrogen hubs being developed at ports. You can produce electricity, produce green hydrogen using electrolysis. The hydrogen could supply the port's own cranes, forklift trucks, local and regional operators of fuel cell buses, HGVs, waste collection vehicles, as well as hydrogen to use ammonia for bunkering facilities for the ships and the vessels that will be calling in the port. So the transport sector is definitely making that transition towards decarbonization. Rail is also going to do that. Rail can lead the green recovery. It's a green mode of mass transit. It contributes only 2.5% of greenhouse gas emissions and only 0.6% of total UK emissions. All the emissions that come from railway traction comes from diesel trains, actually. Shifting freight from road to rail offers 76% carbon reduction. The industry is innovating with into the city concepts, bringing light goods to city centers, use of vans and trucks. And the government has announced plans to ban petrol and diesel engines by 2030. So rail sector definitely will shift to aid this modal shift. Train electrification is expensive, but it will be the lowest cost option for whole life cycle costs. So over the next 30 years, there are plans to electrify about 11,000 kilometers of rail track. Battery trains, yes, they are in the news, quite exciting. Hydrogen trains are in the news. They will be more used for branch lines where high track electrification costs do not justify the business case. Non-traction power, even railway stations, depots, and buildings looking to decarbonize by using solar PV combination with battery storage. Car parks can be fitted with EV charging infrastructure to allow rail users to charge their EVs while they are commuting into main cities as well. Those are images on the right that shows the different concept trains as well as the first prototype trains, battery trains, the Alstom Breeze hydrogen train, Hitachi Hydroflex trains, so which are all running on trials at the moment, waiting for the first mass deployment. And which finally takes into, I've got one slide on heat, and this is about reducing, again, GHG emissions, because a lot of emissions comes from the heat, like between 65% of our homes will be using hydrogen for heating the system transformation scenario in national grids. But there will be a combination of electrified heating as well as hydrogen-based heating. In the more immediate term, you will see electrified heating, which means heat pumps being deployed. The government plans to install about 600,000 heat pumps annually by 2028. Those images on the right, like a picture, it's a Mitsubishi heat pump. They just act as refrigerators, it just, the principle is opposite of a refrigerator. Provide warm water, also for radiators or hot water supply. So by 2050, you could see about 20 million heat pumps or 70 million homes with hydrogen boilers, with as many as 8 million homes actively managing the heating demands. There are hydrogen trials which are being deployed to blend in to the network, about 20% hydrogen for use. This is a trial project being done at Kiel University. And that's it. In summary, what are the benefits of utilizing renewables and flexibility? That you can reduce the cost of energy, you can ensure price stability, you can integrate renewable energy assets, energy storage technologies, automate network operations, and generate additional revenue. I'll leave you with this small story, like you're probably wondering what's that image of a river with a stranded bridge. And this is a quite interesting story about the Choluteca Bridge in Honduras. And this region is famous for storms and hurricanes. A Japanese firm built this bridge in 1996 and was open to the public in 1998. And Hurricane Mitch hit the region in 1998, and all the bridges in the region were destroyed, all but one, the new Choluteca Bridge, which you see in the picture, that remained unaffected. But there was a problem. The road connecting the bridge was swept away. Even the river had changed its course. It created a new channel, and the river now flowed beside the bridge. It became a bridge over nothing, a bridge to nowhere. I think the lessons we need to take from this is we focus too much on solutions to a given problem. Sometimes the problem itself changes. Built to last may have been a popular mantra, but built to adapt could be the way to go. That is what we need to be doing, adapting. So with that, I will close my presentation and I will open the floor to questions. Happy to take that. Thank you.
Thank you, Sagnik. That was a fantastic presentation with lots of bases covered. We've got a whole range of questions here. So between the two of us, if I ask you some of the questions, would you like to try and field some answers?
Yeah, we'll certainly
So
You can go.
the questions are pretty varied, so I'm going to take them all one as one, really. First one is a very current one, especially after the Texas incident, where wind turbines got damaged due to snow. What could be done in future? Since it's a topic about the road to net zero.
Right.
Any views on that from your wind turbine experience?
Yes, actually, wind turbines do have de-icing technologies. Of course, like I worked with Vestas, and I do remember there was one of those considerations of de-icing, and there were things around the turbine blades that were coating around the blades to actually prevent icing. And the wind turbines that were in Texas, have been there around for a long time, but it cannot be blamed only in the wind turbines getting iced, because actually the power plants as well had got iced over, so they couldn't be fired up too. And the grid, and there was problems around the grid, which is a standalone grid. The Texas grid is not an interconnected grid. You couldn't rely with the trading patterns. So it was a perfect storm, like who actually intervenes to support that. So you cannot blame the technology. It was a combination of different things that created this situation in Texas. I think you'll find more findings coming out from the investigation and the post-mortem analysis, and finger pointing and blame shifting between the different participants.
I think if you look on the BBC website, you'll find a little bit of investigation that says it wasn't as simple as the wind turbines froze. But so as you say, the investigation will come up with some results that there were some special features of the Texas distribution system, I think. The next question, really, net zero is a meaningless word like carbon capture. Do you think we need to use more meaningful terms? I mean,
do we need to do what?
I'm not sure how this question is going to work, because you have to use some phrase. So I understand the question, but I'm not sure how you can raise an answer.
Okay, net zero. Yes, I understand what you're saying, like carbon capture, because net zero, what does zero means? Because in every activity, human activity, there's a production of carbon dioxide, there's an emission of carbon dioxide. Net zero is how can you offset that carbon dioxide production? If you can capture it, well and good. If you do a negative emission process where you offset that, the net result has to be net zero. You cannot get rid of everything, every carbon generation activity. So net zero is at state. So
we'll move on a question, I think.
Yep.
This might mean something to you more than it means to me. Are you working with Ambri, that's AMBRI, and their liquid metal battery technology, which aims to solving the renewable storage gap? I've not heard of Ambri.
I've not heard of Ambri, but I think any battery technology solution can work very well co-located with variable sources of electricity, whether it is solar PV or wind turbines. Whenever there's excess production of renewable energy, which is not being used, you can use that electricity to charge up the battery, store that in the battery, and make it available for use at a time of day when you need it, when the sun is not shining or the wind is not blowing. So any energy storage solution alongside a renewable source of generation would make sense, whether the technology is liquid metal or zinc air batteries or sodium sulfur batteries or flow batteries or hydrogen as energy storage. Yeah.
So we'll move on, because we've done. One is a sort of numbers question. So it's from Tom Broughton. Where did you get the figure of 180 million metric tons of CO2 from CCS? He said the 6 carbon budget report indicates that 720 million metric tons required by 2050. So
right. I was looking at the climate Commission for Climate Change, that is a CCC report, that is not the 6th carbon budget report. I didn't look at that one. And the Committee for Climate Change, that's a different report. And I think we published it last summer, so that is where it was mentioned. has repeated up. But I'm happy to be corrected. There's even more required. There's a case for CCS. I was not disputing the case for CCS. I was just saying that you need more, that you will need CCS until you get to a stage where you will not need CCS. You can just make all green production.
Well, we've still got a good flow of questions, so I'm going to move on because we give every person's question a chance. One question I think was, will it be possible to get the presentation live later? Well, the answer is yes, it will, because it will be on our local network's YouTube channel. And as I said, if you search for that, you'll find this presentation in a few days' time. Well, this is an interesting one because I've come across this question before from Andrew Poole. How are CO2 emissions account for to cover the manufacturing, installation of electricity generation, distribution, sort of, and he gives an example. For a car, about 50% of the CO2 over its life is sort of its manufacture. Yep. And I've heard that of nuclear power stations that says most of the, all the concrete that goes into building a nuclear power station, it's got a huge CO2 footprint from its construction.
Yes, yes. And that is embodied carbon, and that is the next challenge for all businesses as well, and supply chain, to report their carbon footprint. Because ultimately where it's getting used is what is the life cycle. So here's the example of whether it's a construction project, whether it's car manufacturing, how do you account for the carbon dioxide emission over the life cycle from production right to use over the lifetime. So you have to count, measure, and there's more onus and responsibility being placed on supply chain to report that in the manufacturing process, so that when innovation is do that.
We'll move on. Another interesting question, because this comes up to it's almost like one version of the nuclear story from an anonymous attendee. Decommissioning of renewable energy systems are still relatively new, so this is the end of the cycle. Is decommissioning phase included when calling it zero? The wind turbine cycle comes to an end.
The decommissioning phase, I don't think this question makes, I'm struggling to answer that one. Like decommissioning of, yes, really, how's that linked to when calling it zero? Because decommissioning phase is when you take away the installed infrastructure, you remove it. But actually, zero comes from the power produced and the what is the fuel source for wind or solar? For solar, it's the sun. Wind energy, wind. So there is no fossil fuel being burnt to produce that electricity. And that is where the zero comes from, that these are clean sources of energy. That is where the answer
we'll just keep cruising on, because it's an interesting one about decommissioning. It's part of the whole life cycle, but I'm sure that'll have to work through. Can the electricity network cope with electricity demand with the EVs and air source, ground source heat pumps?
That is always, that is a holy grail. Like, can it cope with it? Yes, if I believe National Grid, they're very confident that they can meet that demand. Yes, there is quite a bit of headroom available in the network to do that. And there's more expansion required as well. And that is why you have all these sources of electricity to also come up to for the demand.
Next one's an interesting one. I know you can answer this one from where you look at the energy markets. I'm just going through all my questions here. There's lots of them. I'm going to pick a few. I'm lost. I'm gaining questions here, Sagnik. That's not my problem. I'm going to pick a few of these at random because we'll go on. Surely COVID has shown that consumers as individuals make very little difference. See, holiday flights dropped off with no change in our footprint. It's heavy industry and manufacturing that needs to change. I don't know how you can comment on that from your presentation. It's a more general question, I think.
It is a more general.
Yeah. But when I heard this, the Manchester's Tyndall Centre has published figures on UK-based carbon budgets. These indicate the bulk of reductions need to be made in the present decade. Most of the technical solutions discussed seem to be much longer timescale. How can the discrepancy be resolved?
You just have to, that's commercial scale, like more and more people get behind the technologies and there's more commercialization and regulatory incentives which will incentivize that large scale uptake of these technologies will be deployed. And as you can see that if offshore wind has to quadruple by 2030, so this decade you'll have offshore wind electricity available. Hydrogen is also going to scale up and there's going to be more green hydrogen production. So yes, commercial scaling up is happening and that will take care of the discrepancy.
I'm going to take one question, like multiple questions, because it's much the same. A few attendees have asked roughly the same question. And this is the story of the future role of electric vehicle batteries being used in the electrical distribution system. So at some point, the car battery is consuming power, and at other times it's giving up power. Now, I know that's a fairly interesting topic at the moment that says you drive to work, plug your car in, and it runs the office, and when you go home, it does the reverse. Any views that from your point of view? Because that's nearer to the mark of what you're doing, isn't it, Sagnik?
Yes, so is it about getting billed for your car battery charging? So if the battery is full and the grid takes half of it, then the battery charges up later. Is a car full to achieve a full battery? No, because it depends how the time of use is happening. Like if the grid is taking up half of the battery, you're getting paid for that electricity you supply. So you're not getting ripped off. you only pay when you charge. When you give your electricity to the grid, you get paid for it. The grid is not going to take away your electricity and not pay you for it. That is vehicle to grid charging.
I'm sure there's business models to come along to complement that, but I can imagine if you of using cars as car batteries as an energy source.
Yes, it is happening. Business models are evolving, and
yeah, so I can see that working.
Absolutely, absolutely.
What about hydrogen, which is one of I'll just pick as hydrogen as an energy source for planes and other transport, and it's so explosive.
Yes.
Well, it's like all things. 250 tons of kerosene in a plane is pretty explosive too. Energy is energy, and you have to have the systems in place to manage it. Yes. I can speak for that one because I used to be heavily involved in the storage and transportation of hydrogen.
Correct. And yes, hydrogen is known for causing metallic embrittlement. So you have to.
We could have a whole webinar
discussion around it.
Hydrogen introduced test corrosion cracking, couldn't we? That would be good fun.
Exactly.
Hydrogen trains already used in Germany. Are plans for trials deployments in the UK? The answer to that is yes, isn't it, Sagnik? It's in your presentation.
Well, what's the question again, Rob?
Using hydrogen. Is the trials of hydrogen-powered trains in the UK as in Germany?
Yeah, they are happening.
That's going ahead now, isn't it?
There is trials. In Germany, there are already some trains running, like the Alstom Island train is running. And in the UK, the Breeze trials are happening with Alstom, and then the Hydroflex train, the first, but small. They're not like commercial service trials. They're just testing and trialing the. It's not a commercial trial, but some of the trains in Germany are already running hydrogen commercially.
How will UK PN cope with extra demands on urban areas with the existing infrastructure? No real estate space for additional transformers, fault levels. Well, this is about infrastructure. There's only two sources of, so I don't think you can answer that really, Sagnik. In the end, it's the people with the money have to pay, so it's either the government or the consumer.
Yep.
That's how it's always been.
Exactly.
John Worley, what future do you see for floating wind farms? Well, I think that's on one of your slides, isn't it?
Yeah, floating wind farms will also take place. Yeah. Yeah,
So
there are investments being made, and there will be 1 gigawatt of floating wind farms. Start oil is high, what they call high wind installation, and that was a few years ago. Yeah.
We have an interesting question. It almost goes back onto the previous one, but it's Mike De Silva from Bechtel, one of the major engineering companies in the world. Sagnik, I understand that hydrogen can be aggressive to the current gas distribution network. So it's changing from natural gas to purely hydrogen could be very expensive.
I don't think there is at the moment, it's about blended gas. So yes, you're right. If you just pump in full H2, then you have concerns around the pipeline and the metallic condition as well. So at the moment, they're all trialing 20% blending into the natural gas network. Hydrogen.
I think it'll be a long time before we go to a pure hydrogen distribution, at least for homes.
Correct.
Are there increasing for local for on-site generation as part of the net zero targets? Well, the options. So there's about local generation, small footprints, offices. That's sort of going ahead anyway, isn't it, in a way?
Yeah. Like, is it about the extra energy demand in urban areas? Is it what it is?
You mentioned that this is one I think is a very interesting one, which is I know this is a hot topic base a while ago. You mentioned how 25% of the new renewable power is connected at the distribution level.
Yes.
Is this visible to the national grid control room? I know there was a lot of debate about connecting generation of whether it's green or non-green at the distribution level because it causes system instability.
Yes, and it is happening.
Is this power source visible at the national grid level? Or?
Yes, so what is happening is the distribution network operators are becoming distribution system operators, and so they have. So there is interaction between national grid and the distribution operators as well, because things which are historically in the national grid's remit, because generation would connect at the national grid voltage, is now actually happening at distribution network level. So distribution network operators are not just network operators, they are moving into distribution system operators. So they can actually manage the source of generation that is being connected. And that is what is meant by active network management. They can actually, when you apply as a generator to connect to the network, you have to sign up to some of the connection agreements where it says, like, we can drop you off the network if there is excess generation in the network. So DNOs are making those decisions as a DSOs, especially with all these EV charging, electric heating, solar PV, wind farms, all connecting, and network operators moving to that. Yes, it's happening.
Sagnik, I think we maybe should stop because your sound quality for me is very poor.
Has it really become poor now? It was
fine.
Is it better now?
Are we struggling? It's like a loss of bandwidth, I think. So I'm not sure you can do anything about that.
Are you still struggling? You cannot hear me now anymore? Really bad, is it?
Yeah, so if I can't hear it very well, I think some of our friends cannot hear it very well either.
Right. Okay.
So I think we've got plenty of open questions, but I'm not sure if people are not hearing it as I'm hearing it. It's very good.
Because I can hear you nice, loud and clear, you know. But some people are saying, people are saying they can hear okay.
The sound quality I'm hearing is not very good, unfortunately.
Okay, but you can see messages coming up. Sound is fine. I can hear well.
Okay, if the sound is fine, I'll carry on. Okay, so maybe just to me. So I'll carry on down the questions because they are really good questions. Next question after the hydrogen trains one is there any view on whether peer-to-peer microgrids could feature in consumer-led strategies?
Oh, wow, that's an interesting question. Peer-to-peer microgrids, yes, that is going to happen as well with all these blockchain technologies, which will be tracking transactions between neighbors. And yeah, if you're producing solar PV on your rooftop and you want to sell your electricity to your neighbor, yes, they can. And yes, that will happen peer-to-peer, whether on a direct basis or in a community energy scheme, yes, it will happen. And there are already trials which are happening around the Western economy on this.
This is also what I'm going to script that question because I think it's going around in a loop really. I'm going to pick questions that actually, if we depend on offshore wind so much in the future, will it cause problems to marine environments and shipping? How can we deal with this?
What was the question again?
If we depend on offshore wind so much in the future, will it cause problems to the marine environment and to shipping? How can we deal with that?
No, I think when offshore wind is deployed, they are deployed taking into consideration subsea cable routes and also shipping lanes as well. You don't just site the wind turbines at sea randomly. You actually look at the seabed conditions, you look at where the traffic, the ocean traffic is, and according to that, the land is consented, the zones are consented, and the wind turbines are accordingly deployed and installed so they don't get in the way of traffic as well. So ships, they're not a hazard waiting to happen for ships and vessels. It takes into account.
I'm going to pick another question. How much has the whole life cycle of renewables been accounted? One example is that some electrical components on wind turbines cannot be recycled and therefore create waste.
Yes, yes, wind turbines do last for 30 years, and I think there is a move to as much as possible recycling of equipment, but the blades themselves, they are carbon fiber epoxy resin blades. I don't have an answer for that one, how that is recycled. Maybe it is shredded and converted into carbon fibers again, but I'm not close to the manufacturing technology anymore and what they're doing, recycling those, recycling the carbon fibers that go into the blade themselves. But the turbine towers are made of steel. They can be recycled for scrap steel. The transformers, the switch gears, yes, there's a lot of recycling, reclamation happening. Cables get reclaimed as well, but cables last for 60 years, long time, actually. So yeah, you're again getting into the realms of embodied carbon.
So I'm trying to pick things that
I like somebody's response to the blade question.
I think there's some of these questions are so specific, they're not reasonable to, for you to cope. I think we should really let you, unless you're happy to carry on, but there's a few here which I think are beyond what you can answer. So how is COP26 focus on net zero? Well, I think you can't really answer that question from a, your view of the world. You've got to be in the UN or
yeah,
G8.
I can always take a view on it.
Ken Fisher says my question seems to be bypassed. I'm going to find Ken's first question. He says it's been bypassed. I'll just scroll up to the questions and see if I can find Ken. Ken Fitcho at 7:37. There's a lot of talk about electrical vehicles and transport generally. If this is a contribution to the answer, but where is the vast amount of lithium and other special materials for use in batteries coming from? It does not seem to be adequately considered with regards to effect on the environment. Well, I've heard that comment before about lithium batteries. Where do you get lithium from? I know there's things in South America and there's talk about mining it in Cornwall, of all things. Yep. Don't know. Can you have any comments on that, Sagnik?
Comments around lithium-ion batteries.
Well, the issue is if you're going to build the batteries, where's the lithium going to come from, and how are you going to get this lithium in an environmentally sound way?
Yeah, because it is lithium is mined. There is quite a few deposits around the world, and yes, you would mine them in a normal mining process. But yes, as with all mined material, they have a finite life, and now it depends upon are you plundering the earth for all the resources, or are there alternative technologies and materials available? So that is the only solution. Like if there is another solution to lithium ion at some point, who knows whether it be hydrogen or some other form of technology which is environmentally friendly, that will be the one to go to future. That's all I can say. Like the mining is not an environmentally friendly process by its very definition.
I've got to pick a question here because I think we've got to have to give a rest in it. But this is for a gentleman called Jeff Shaw. Now, I have a friend called Jeff Shaw, and I'd be interested if this was my old friend Jeff. But an implication of the presentation is a huge growth in the number of sources of electricity to the grid and potential flexible demands, including from smart battery electrical vehicle chargers, solar, wind farms. How is the control of all these distributed suppliers and demands be addressed to ensure frequency is maintained? Now, from your company's perspective, that's the heart of the matter, isn't it? It's system stability with all these sort of disparate sources of electricity generation and consumer.
Yes, exactly. No, absolutely. Like ensuring this flexibility, ensuring this that there are flexibility platforms being created by distribution system operators where you can trade in this flexibility and to make it available to the grid to actually stabilize the system and stabilize the network as well. So it is the bread and butter, whether it is a distribution system operator, whether it's a national grid level. This is a constant, it makes it more interesting and lively in the control room for all the engineers and the system planners to balance this challenge, this requirement. Yeah.
Well, I've got a question here. I've got two things here, Sagnik, we're going to cover in one go. And Arthur has put another question on saying, why have I skipped his question that he put in at 7:40? And I think the answer is listening to our next webinar. What is the state and outlook for tidal and wave power technology? How does it levelize the pounds per megawatt hour using this as well? Come along on the 27th of April, and you can listen to the project director for the Mersey Tidal Power Project, Martin Land, and listen to what Martin has to say. Exactly. So I hope that helps you, Arthur, and it helps me publicize our next webinar too. So that's really good.
Absolutely.
So that's a few comments. So about fish. One which I'm not sure you can answer because it's too broad a question, but how will jet and torus impact it? So the nuclear fusion rather than fission, but I think that's almost a topic in its own right. I don't think it's one.
I'm sure.
You know, the old torus has been around for centuries, not centuries, but decades.
Yep.
We'll just have to wait and see how that pans out.
Correct.
Right. Now this is an interesting one because this is a hot topic. It's from Jim, and it says, whilst proximity cooling water is obviously helpful, this is about nuclear, given the experience of storm surges and tsunamis, why does the UK keep building nuclear plants on the coast?
Why does UK build
type debate, isn't it?
Is the question around technology? Like, why is nuclear built along the sea coast? Yes, given the that's a good question. Like from why does the UK keep building? Because if you think about it, there is already an existing site, and what they're trying to do is, if that existing site has lived its life for 40 years, 60 years, and it gets decommissioned, there is still business case for that local economy, local ecosystem to site a new one, because you wouldn't then try to build a new nuclear plant in how to say, a residential or industrially populated region. Nobody wants a nuclear plant in their backyard, do
maybe future nuclear is a topic for our group in going forward. I'll try and find somebody to come and talk about that, because we have the Office of the Nuclear
yes, we have it, yes.
We have some contacts in that, but I think it's a good question, but it's a bit hard for you to answer that. David Fearon. The talk about direct air capture, do you believe this could be even more significant in CCUS? What do you think of this, how realistic this technology is? So this is just trying to extract CO2 directly from the air, from the atmosphere?
Yes, that is a direct air carbon capture. So that is what people are talking about. But I'm not very close to the DAC technology, but because CCS is almost like you tap the chimney and you directly capture the emission from the exhaust from the chimney. That is CCS, the CO2 is extracted.
I think that's
but I'm not close to the DAC, how the DAC technology works, but I've heard about that. Well, yeah.
Or extracting CO2 from the atmosphere.
Yep.
Right, Germany is making a point. Given the CO emissions from my German diesel car is the same as Prius, it has a lower lifetime emissions. Well, I think that's a general case. I think it's beyond your presentation, Sagnik.
Exactly.
There's energy in building cars, and whether battery or diesel, and eventually they are disposed of, and there's a complete environmental impact life cycle to be dealt with on virtually everything we do, including this computer I'm using tonight. What happens to it in the end?
Let me put it this way. I'm just personally waiting for hydrogen fuel, so passenger cars to come out in probably 10, 15 years. Maybe. So we'll see how it goes.
I think we must have done now lots of questions now.
About 30 minutes of questions. Yes, at 7:45 we started.
I've got a thing from Kevin about Ambri, AMBRI.
Yeah.
So I'll pass that on to you. I think the time is to say thank you very much, and thank you for your time. And I'll speak to you in a few minutes. I've set up a little Teams meeting to do a little review. Thank you very much for your attendance tonight. See us again at our next webinar on the 27th of April, when it will be about tidal barriers. And I think that will be very good. So I think that we should close.
Well, thank you very much indeed, Rob, and thank you everybody for your questions. I really enjoyed that rapid fire session. So thank you for listening in. Appreciate that.
Right, so I'm going to end now. See you in a few moments.